Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be building, setting up and flying the Tyro79. 79 standing for 79 US dollars, which is an amazing price for what you get in the package. And I guess you could say it is the baby brother of the Tyro99, which for me was a little bit hit and miss, but I know a lot of people bought that model, they enjoyed it and it got them into the hobby, and I think this guy is going to do the same. Now, I've broken a rule in this build. I've switched out a couple of components, but don't worry, they are cheap components and I think it is necessary. The first one being the props. So these are the props they give you in the package, and I imagine they can't give them away these days, and that's probably why they have included them in this cheap package here. They are a 3x3x4 and they are a bull nose, so they've got a flat edge there. They are very inefficient, but they are strong. I don't think they're going to be a good pairing for this motor though, so I've switched them out for the Dell 3056, which is higher in pitch but it's a lighter prop, so I think it's going to be a better pairing for this motor. And just like the Tyro99, it's a unusual choice of motor for a 3-inch copter. So it's a 1607 2800 kV motor. We've got a naked bottom here, which is quite nice. But the last time that I put a 16-stator motor on a 3-inch copter was this 3B model, and it was a 1606, slightly higher kV, so 3500, and it ran really hot. Now, the designer told me that they are designed to run hot, but the RC InPower 1506 4100 kV motors outperformed these motors, so I assumed that the 16-stator motor was overkill for a 3-inch. So we'll have to see how this one performs, because we have a 1607 motor on here, which is a slightly taller stator as well as it being wider than the 15-stator motor. Now, unfortunately, just like the Tyro99, the wires are plastic, so a soldering iron is going to melt them. It would have been nice if they were silicone, but of course they are working to a price. The frame is a unibody, so it's easier to put together than the Tyro99, but because we've got these aluminium sides here, it's still a little bit of a tricky build. And you aren't given any instructions in the box. There are some instructions on Banggood's website, but they aren't very clear, so hopefully this video will help you. Now, one of the other things I've switched out is this silicone battery mat. Now, in the package, they give you one of those sandwich plates, which I find just adds weight and doesn't protect the battery at all. And it comes with a little bit of foam. The problem is the foam doesn't stop the battery from sliding. It's also too thin, so the screws dig into your battery. So this is very cheap here, and you have to cut it to length, and it is thicker than the screws, so they don't protrude into the battery and you won't get marks or damage your battery, so I'll link that in the below as well. And the last thing I have changed, or added you could say, is this foam on the top here, because I believe we could potentially put a Mobius Mini on the top here, because as you can see, the VTX does not protrude out of the top like the Tyro99. So yeah, I think if we put some foam on here, we get reduced jello from the Mobius Mini, and we've also got this hole here, so we could put a strap through it or a cable tie and potentially carry a HD camera with this guy. So the ESCs are a 20 amp 4-in-1 BL Heli S with a 25 amp peak. Now, Banggood's website says that it's suitable for a 2 to 3S battery, but I think it's going to be fine on a 4S. In fact, the ESC is rated for a 4S, so I'm going to be using this GMB 650 mAh 4S battery. And if we do the calculations, so this battery is capable of 80 to 160C. It's never going to reach 160C. So if we take 80C and times that by 650 milliamp, that's around about 52 amps and 20 amps. So you have to remember that's 20 amp each ESC, that is 80 amp, so we are well under with this. And then if we take the 25 amp peak into consideration, we could potentially use a 850 milliamp 4S battery, because this one here, the R-Line 95C, if we times 850 by 95C, I think we get about 82 amps. So that also covers the 25 amp peak, because that would make the peak 100 amp in total. Then for the flight controller, we have got a F4. It is a 32 kilohertz capable flight controller, apparently. It's got Betaflight on-screen display and everything is plug and play, but it's also got some breakout pads, which you'll see in the build video. Then we have the VTX, which this time is part of the stack, so it doesn't protrude on the top like the Tyro79 did. It is switchable up to 200 milliwatts, only this time it uses smart audio, and it's TBS smart audio as well. It's using a micro UFL connector, and that's another modification I have done. I've secured it down with some adhesive, and you'll see that in the build. And we also have the antenna, which is a linear antenna, and I've secured that down with a cable tie. We have an XT30 coming out of the back here, and for the receiver I am using a XM Plus. It fits inside just about, but it's a tight squeeze. It comes with a Futaba style connector. Then we have the camera, which at first I was a little bit worried about because it has the same aesthetics as the camera that was in the Tero Q215, and that performed terribly. However, I'm pleased to say that they've either changed the settings or the internals, because the quality seems a lot better, and we have got a 2.1mm lens up the front here, and it is a CMOS camera. So let's take a look at what you get in the box. You're greeted with a foam pad. We then have the carbon fiber unibody frame, which is in a sealed bag. Then we have the VTX, which is also in a sealed bag, and it's got the micro UFL connected to it. We then have some carbon fiber spanners, which I'm not going to use. We've got the battery strap. Then we've got all of the wiring. We've got some cable ties. We've got the carbon fiber sides. We've got the sandwich plate and foam landing pads, which I'm not going to use. We've got all of the screws and some spare screws. Then we've got the propellers that I'm not going to use. And then we've got some spare locking nuts. Those are the aluminium sides. And then this is the stack. And as you can see, it is soft mounted, which is really nice. This is the camera. It has a lens cap. It's a 16:9 CMOS camera, and it's got a 2.1mm lens. These are the motors, and as you can see, we have got locking nuts on those as well. They are directional, but it's nice that we've got a spare set. Now the first thing you want to do is lay out all of the dull screws in a line, and what I'm going to do next is I'm going to remove the nuts from the stack. This is so that we can get to the ESCs and tin them up, and also add the XT30 connector. The only problem is that because a lot of this stuff is plug and play, one of the nuts is really difficult to get to, so I just removed the nylon screw underneath to get them apart. So the next thing I'm going to do is tin up the XT30 connector, and then I'm going to flip the ESC board upside down, and I'm tinning the minus there, and then the next one is the plus. This is so that the low ESR capacitor isn't pulled down when the wire is pulled down. That's the plus going in there. Then I'm taking one of the dull screws, and I am putting one of the nylon standoffs in, just hand tightening it there, and then putting the stack over the top, then using the rest of the dull screws to screw those in. And make sure you don't over tighten them because it's going into nylon. And then I'm going to tin all of the ESC pads up, so I'll speed that up so you don't have to watch it in slow motion, but it's very important to do. So next I am screwing the motors in, again using the dull screws. It's a 1.5mm hex driver, by the way, so you do have to pay attention to the direction, and I'll show you at the end. So that's one motor in, and then I have skipped forward, and this is all of the motors going in. Make sure that you tighten everything up. You might want to use Loctite because these screws aren't that great a quality, but if you check out the direction there, look at the color of the nuts, and that is the direction of the motors. So next, I'm tinning up all of the wires. You have to be careful because the wiring is plastic, so it can burn, but yeah, if you are really careful, then there's no problems. So I'm just now soldering in the ESCs. It doesn't really matter which order they go in because you can change them in Blheli suite later. However, I did notice they were cut to the right length, so I just put them in at that length. So this is the flight controller close up. You can see at the bottom we've got a jumper pad for inversion, so S-bus will be the inverted pad and PPM will be the uninverted. We've also got the option to add an LED board, and we've got some breakout pads here as well. So we've got TX1 and RX1, we've got S6 and S5, so that is for extra motors, so I guess you could remap those. Then we've got RSSI, so external RSSI, and then we have got, I think that's current, and you can see we can add a buzzer at that point as well. We've also got a TX2 and an RX2 pad there as well, so yeah, not bad really for the price, but this is meant to be plug and play. So let's take a look at the underneath of the board. And again, you can see we've got some breakout pads. So we've got the cam, the VTX, 5 volt and ground. And then if I flip it around, we've also got PPM, S-bus, 5 volt and ground, and 3.3 volt. And we've also got breakout pads for the ESCs if you want as well, which I thought was pretty nice, again, for the price. So I am bridging the inverter for S-bus there, and then you can see that close up. And now I'm plugging in the ESC wire, and I'm tucking it underneath just so that it's neat, otherwise it sticks out the front and gets a little bit messy. Then I'm sticking the flight controller over the top there, and then I'm just screwing in that last screw. As you can see, it screws in just fine, so this is a good method actually. It worked quite well. Then I'm plugging in the ESC wire to the flight controller, and then this was pretty tricky, getting the nuts back on. I used a socket driver to sort of start it off, and then I used my fingers to sort of finish off the rest to get it to the bottom. But yeah, as you can see, we've got a lot of connections there, very close to these little nuts there. So yeah, just finishing it off there with the fingers. And that's the last one going in there. Again, starting it off with the driver and then finishing it with the fingers, and that's all of those on. So this is a close-up of the VTX. We've got breakout pads here as well, and then on the other side you can see we've got the micro UFL connector. It is loose though, so I'm going to be using some adhesive to secure it in place. It is this stuff, it's the stuff that they use on the XM Plus, and they use it on quite a lot of stuff actually. I think I got it off eBay. I think Jack or Bright Until I Fly put me onto it. I use a screw to make sure that everything is covered, and the underneath of it as well. It does take 24 hours to dry, so bear that in mind when you are building this, but that's what it's like when it's dried. So now I am taking the shiny screws, and those are the screws that screw into the side. So there are 3 short ones and 1 long one. The long one is for the SMA adapter at the back, even though it doesn't have an SMA connector. So yeah, I'm also putting the camera screw in here as well, and that is a Phillips screw, that one. And then you can adjust the camera as you wish. This is the longer screw that goes in the back for the SMA adapter. I just sort of screwed in the SMA adapter and then tightened it up with the hex driver at the end, and then as if by magic I did the other side as well. I didn't want to make you watch me do both of them. So this is interesting. This is the pin for the camera, and it's got 3 pins on one end, but if you look at the connector, it's got 4 pins. You have to be very careful here, or you could end up with a bang. So you want to make sure that the red wire goes in to the closest pin, and then you'll have no problems. But I thought that was a little bit of an oversight there, but I'll forgive them for the price. Then this is where the VTX connector goes in. It doesn't really matter of the colours because it is like for like, but you know, you can put it in this way if you like, with the black wire facing the back. That worked for me, no problems. Then this is the receiver wire going in, so we've got a Futaba connector at the back there, which I utilise. So now I'm putting the nylon standoffs over the top of the nuts to give a little bit of clearance for the VTX. So there's 4 of those to go on. However, I did have a problem with one of them. You can see it hasn't quite come out of the mold correctly, so I just got some cutters on there, and that seemed to sort the problem out. So now I'm tucking the VTX wire underneath the VTX itself so that it's nice and neat, and we can just plug that straight in. And then we should have some nuts that go over the top of there, and this time we don't have any connectors in the way, so I can use my driver here to tighten them. But again, it's nylon, so don't do them too tight, otherwise you can ruin the thread. And I cut the tops off here just so that we have got enough clearance for the receiver to go in. So this is the side going in, and again you're going to be using the dull screws here, and just make sure you haven't trapped any of the plastic wires for the motors. There are 2 of those that go in, so you just have to line them up. Now I'm plugging in the camera. Next I'm going to use my test clamps to upgrade the XM Plus so it outputs the RSSI on channel 8. That's the signal wire going in, that's the ground, and that is the VBAT. I've already uploaded the firmware file to the SD card, so you can see there RSSI 8. I'm going to flash external module, and you'll see the lights flashing on the receiver. Now at this point you can also bind the receiver to the Taranis. You have to turn on the external RF module while holding down the bind button of the receiver, and then go into bind. We want telemetry off and then select enter. Make sure you've got failsafe set to no pulses as well. We can exit out of that, and when we turn the Taranis off and turn it back on, we should get a green light showing that it is bound. Next I'm going to set up the model, so I'm going to go into the mixer and I'm setting up a arm switch, so A for arm, and then I'm going to select this 2-position switch here for that. Then we're going to go back and we're going to set up a mode switch, so I'm going to go to the letter M because I'm lazy and don't want to type it all out, and then I'm going to select this 3-position switch here for the modes, and then I'm going to exit that and go to channel 7, and this is going to be for the buzzer, so B for buzzer, and then we're going to go down to the source and I'm going to select this switch for the buzzer, and that is the model set up. Next I'm going to solder the 90-degree pins in because this model is using the Futaba style connector, and that is going to fit on these pins. I'm just cutting off any excess underneath so that they don't protrude out, and then I'm using my own heat shrink because they don't provide heat shrink with the XM Plus anymore. So next I'm plugging in my XM Plus, so you have to pay attention to the wire order of course, but that fits in just about on top of the VTX, and then I'm taking the antennas and pulling them through the gaps in the side there so that I can mount them, and then I'm screwing in the other side again using the dull screws, and then that is the front one that is going in. These are the shiny screws again, and I'm just going to screw all 4 of those in, but there's nothing going to be sitting on that plate. I guess you could put your receiver on that plate. So this is another strut across the top there, I guess that is just for a bit of strength. And then I'm feeding the linear antenna through the back, and I'm using a cable tie just to secure that in place so that we've got a better angle on it. And then we've got the longer screw which needs to go into the other side of the SMA adapter. Now I'm using my own cable ties. This is to mount the antenna for my XM Plus. I'm using the arms. I'm not using their cable ties because this is my heat shrink and it won't fit over the top. I think it's 3mm heat shrink, yeah, so that's why I use my own cable ties. It also neatens up the wires for the motors, so I've done the same for the back and for continuity purpose. And speaking of continuity, at this point we want to check the continuity. So we want to hear a beep to show that there's a short on the continuity setting, but we should just get a chirp from the copter and not a long beep. If we get a long beep, we have got a short and we need to rectify that. So here we are in the Betaflight configurator. You get it from the GitHub website. You'll want to get the Blheli S configurator, which you also get from the GitHub website. I will link them both in the below. And if you are new to this, you'll want to install these two drivers here. And if you want to upgrade the firmware, then you can download Zadig from here as well. And on the subject of upgrading the firmware, this flight controller came with a fairly recent version of Betaflight. However, if you know what you are doing, then you might as well upgrade to the latest version of Betaflight, because you are pretty much going to have to do a full setup. And the way that you do that, first of all, you need to plug your copter into the computer via the USB, and you can see up there that it is saying COM16. By the way, if you aren't sure which COM number it should be, all you need to do is just unplug the copter from the USB and plug it back in, and then it should reappear. So we'll select that. So to flash the latest firmware, we'll go into the firmware flasher, and the target is Maytech 411. And at the making of this video, the stable release of Betaflight is version 3.55. I believe version 4 is around the corner, but bear in mind, if you are following the setup of this video, this flight controller has come flash with version 3.51. Now, Betaflight like to change parameters when they do updates, so if you have any of these other firmwares installed and are copying these settings, the copter might not fly exactly the same as mine, so bear that in mind. But if you want to upgrade to the latest firmware, select the latest firmware. I always do a full chip erase because they sometimes change the CLI commands when they do updates as well. So if you've got a CLI dump that you quite like and you paste it into the CLI, you'll quite often get a load of errors because they have changed the syntax of that particular command. So I always do a full chip erase. Maybe the LEDs you can copy, but I usually just do a fresh install. So I usually select manual baud rate or baud rate, however you like to say it, as 256000. Now there are some boards out there that will flash without selecting this, but I find more often than not that it works with this selected and this setting here. So you'll want to come down to the bottom here and then load firmware online, and that will download, and then you'll want to press flash firmware. Now, if everything goes to plan, you'll get a progress bar that goes along the bottom here, and it will install. If you get a failed message up here, something like a failed serial, that doesn't mean that it's failed to go into DFU mode. So DFU mode stands for Device Firmware Upgrade. It just means that there's a driver conflict, so you can either download the Immersion RC driver fixer, but for me that doesn't work every time, and I prefer to use Zadig. So what you need to do is make sure that the copter is still plugged in when you've got this error here, and in Zadig you want to select list all devices, and then in here you will have an option that says STM32 bootloader. I don't have it here because I haven't sent it into DFU mode, but you want to select that and then click update or replace driver. Now this next part is really important. You need to disconnect the copter from the USB port and reconnect it after you have pressed this, and then when you press flash firmware it should work, and I have not had a failure yet, so that is my preferred method of sorting out the driver confliction. But of course you can use the Immersion RC driver fixer if you like. But anyways, I'm sticking with the stock firmware, so let's connect to it. So at this point I just want to mention that we want to have all of the props removed because we are going to be plugging the battery in and we don't want to cut ourselves up. So in this page we can calibrate the accelerometer. That is so that the copter doesn't drift in angle mode if you are a beginner. So what you want to do is probably remove the battery strap and put the copter on a flat surface like I've got it here, and then we can press calibrate accelerometer. This might move a little bit, but mine's completely flat anyways. So if we go into the ports tab, we have got serial RX selected on the UR1 for my S-Bus XM Plus receiver. You will also need that selected for the FlySky iBus protocol, but if you're using PPM then you don't need to select it. And then we have got TBS Smart Audio here on the UART2, and we don't have any other spare UARTs. Now at this point I want to refer to the Copters manual on Banggood because they are piggybacking off the TBS Smart Audio technology. And if you remember earlier I mentioned that this VTX has a switching power up to 200 milliwatt. However, the TBS VTXs go up to 800 milliwatt, so the numbers in the on-screen display don't correspond correctly to the power output. But first I should explain how to get into that on-screen display. So it's throttle in the middle and pitch forward and yaw to the left. And then you will have an option called features, and you can go into there and you'll be presented with SA, which stands for Smart Audio. You can go into there and change things like the band and the channel and also the power output, and that's what I'm talking about here. And it says here that the power of 25 corresponds to the actual 25 milliwatt, but 200 corresponds to 100 milliwatt, and 500/800 corresponds to 200 milliwatt. So I thought it was important to point that out so that you know what power output you are running, because it does not match the on-screen display. Anyways, back to Betaflight, and we'll go into the configuration tab. Now, I think out of the box it was set to D-Shot 600, but if you have done a fresh flash, then it's usually set to 1-Shot 125. So yeah, you'll need to set it to D-Shot 600. I've turned motor stop off and I've got the motor idle speed set at 6%. I find this is a good figure to stop flips of death or death rolls happening. So what can happen is if the idle is too low, in order to match your rate, it sometimes has to stop a motor and the flight controller can't react quick enough and it flips out of control. I find 6 is usually a good figure for most copters. So over here we have got the option to reverse the direction of the motors. Now some people say this helps with prop wash handling and it also stops grass being flung into the camera. Now I haven't really noticed any difference in prop wash handling, and of course you have to put the propellers on the opposite way around, but I have a counter argument to this as well. It may not throw grass into your camera, but it can throw it into your USB port, which potentially could be even worse. So to not complicate things, we're going to go with the props in method. So if I scroll down here, we have got the PID loop frequency and gyro update frequency is 8K, 8K. Now, Technically this board can go up to 32 kilohertz, but I don't think that is necessary. You can see the CPU load there is fairly low, so I'm sticking with 8K and 8K. I've got the accelerometer turned on because for new people in the hobby, they might want to have stability mode or angle mode, if you want to call it either of those. So I've got that switched on. I think out of the box it had barometer switched on, but I've turned that off because the barometer doesn't work very well if the board has one at all anyways in Betaflight. Now I've left the craft name blank, but of course you can put your own call sign in there. It's pretty good actually. It's a race. If you are a spectator, you can tune in and find out who you are looking at, but I tend to find that most people use some strange name anyways, and you can never tell who is flying. So arming over here, so the default value is set to 25 degrees, and what that means is if the copter is pitched forward more than 25 degrees, then it won't arm. It's a safety feature. The idea is if you've got the battery plugged into the copter and you're carrying it and you accidentally hit the arm switch, then it won't arm and it won't cut you up. This does have a downside though. If you take off from a bank that is more than 25 degrees, then the copter won't arm. So I set it to 180, which means that it will arm no matter what angle it is at. And I find this useful because if you are stuck in a tree and you have disarmed, you can rearm it and kind of waggle it out of the tree, but it is a risk. So if you are new to the hobby, it's probably best to set it at 25 and take off from a flat surface. So if we come down here, I have got the receiver mode as serial-based receiver, but of course if you are using a PPM receiver, then you'll want to select PPM. And then I've got S-Bus selected for my XM+, but if you are using FlySky, then you'll want iBus, and we've got DSM2 and DSMX up here as well. So if we scroll down here, I've got dynamic filter selected, anti-gravity, on-screen display and air mode. I think out of the box it had telemetry selected, but this isn't a telemetry receiver, so I've turned it off. Now, I've turned RX lost and RX set on. These are D-shot commands, and I would recommend turning these on because a buzzer is not provided in this package. The flight controller does have a place where you can solder a buzzer, so if you have done that, then you won't need this, but I find it really useful these days, and I tend to stick to this because they are loud enough these days. And it's for when your model is lost in long grass, or if it has lost connection with the transmitter, then the motors will twitch and it'll also make a noise, so I've got that selected. So, power and battery. So this does have an onboard voltage meter, but it doesn't have a current meter, and I've had to change the scaling. So I have got a fully charged 4S battery here, and I will plug it in. Now you'll notice the voltage go up above 16.7 volts. In fact, look at that, 17 volts. But that's because this copter has a capacitor, and it is charging that up, and the power slowly dissipates and it then settles at the correct voltage, 16.8, and the stock value of this I think is 110, so 113 worked for me, but it may differ copter to copter, so bear that in mind. I've also changed the minimum cell voltage and the warning cell voltage to very low. Now if you are a beginner, it's probably not a good idea, and you probably want to set it at about 3.3 or 3.4. I set it really low because I find it annoying, because when you go up on the throttle you can get something called battery sag, and it makes the voltage go really low and the on-screen display starts flashing, and that annoys me, so I set it to low. I've also set the maximum cell voltage to 4.6 in case I want to use a high volt. The default is 4.3, but sometimes it won't let you arm if it is set to that. So I set it to 4.6. I've actually had it where it wouldn't let me arm at 4.5, so 4.6 seems to do the trick for a high volt, but I'm not going to be using a high volt in this video. So on to PID tuning, and these are actually some PIDs that I've copied from a copter that I've used in the past that had a similar weight and was a 3-inch, so we'll have to see how it flies. I have changed the rates. I try to get my maximum velocity as close to 1,000 as possible, but if you are a beginner, I suggest that you stick with the stock rates because this might be a little bit twitchy for you. I also add a little bit of expo in here as well to smooth out the center. And then if we come down here, I've got the I-turn rotation turned on, I've got VBAT PID compensation turned on, and I-turn relax, and then I've got the anti-gravity set to smooth, and this as 5. I think this is stock though, although I've changed the TPA value to 0.3, and that's everything on there. So in the receiver tab, I've changed it to TAER1234. That's because that's what my Tyrannus is set up as, but if you are FlySky, then it's going to be AETR. And earlier in the build, you saw me flash the RSSI firmware to channel 8, which is actually auxiliary 4, so you count down 1, 2, 3, 4, 5, 6, 7, 8, it's auxiliary 4 there. I've also changed the stick high threshold to 2000, and I've got RC deadband in there as 5 as well. It just makes the center of the stick more smooth. And if I turn my Tyrannus on, because we've got the battery plugged in there, just have to have this turn on. And what you should see there is the RSSI value there on the aux 4, and yeah, that was the switch that I had got selected there, so be careful when you do that. That's why we have the props off though, you see. You know, I could have armed it. However, I think these days in Betaflight, it doesn't let you arm it. Yeah, I'm trying to arm it there, but the motors aren't going. I think that's another safety feature they've potentially added, because if you look at the warnings through the on-screen display, it says MSP, which means the USB is connected, so I don't think it will arm like that anyways. But that's everything I've changed in the receiver tab. So into the modes, and we have got the arm set up on the auxiliary 1 here, just as I showed in my Tyrannus setup, and then angle on the aux 2, and then acro and air over here, and then we've got a beeper on the aux 3. I would not recommend flip over after crash with this model because it doesn't have protectors and it could get caught in a blade of grass and burn up your ESC. But if you want to use that, then fine. It's for if you have landed upside down, you can flick it into a particular mode and then right itself, but it does have risks. So the motors tab. This is where we need to change the direction of the motors potentially, because this is a new build. So I've got the battery plugged in here, and if I tick this warning here, and again I will stress the props need to be off, what we can do is we can lift up the master, and this should have all of the motors moving there, and the motors should move in this direction here with the arrow. However, when I soldered everything up, that wasn't the case. So what you have to do is remember which ones are not spinning in this direction. So they are labeled 1, 2, 3 and 4. And the way that you do that is you just lightly touch the motor with your finger and take note of which ones are turning in the wrong direction. And then what we want to do is disconnect from Betaflight, because it's going to use pass-through, so it's going to use the same COM port as Betaflight to change the direction of the motors. So if we go into Blheli suite and select COM16 and then press connect, and then we want to read setup. So you can see I've had to reverse motors 1 and motors 2. Now this may be different, so don't copy these settings. It all depends on whether you soldered each wire the same as me. But yeah, change the ones to reverse that need to be reversed. You don't need to touch any of this at all, and then you can press right setup. So once that is done, we need to disconnect from Blheli suite because it is using the same COM port as Betaflight. We want to now go back into Betaflight and connect, and then go back to the motors tab, tick the warning again, props off, and then we can lift this master up here and check that the motors are all turning in the direction shown here, and they are, and that is how you do that. So next we have got the on-screen display. So I have got just a couple of things on here. So I've got the RSSI value, I've got the timer 2, which is the flight time, timer 1 is the on time, so I don't use that. I don't see why that is useful. And I've got the VTX channel. I find that very helpful when flying with other people, and it'll also tell me which channel I'm on, so I can tune my goggles into it to make sure that it is definitely the right channel and not a ghosting channel. And then if we come down here, I've got G-force selected as well, just because I like it. We don't have a current meter, so we can't do any of that business, but that's everything that I have got selected here. And if we go into the CLI, I will just confirm the version number, but we saw it earlier. It's Maytech F411 and version 3.51, and that is all of the setup. So the copter's looking pretty neat now, and I'm going to fit the props. So as I mentioned earlier, I'm going to be using the Dow 3056 props. So I'm going to show you which direction they need to go on. So with the setup that we have, we want the curve to be turning towards the direction of the motor. So if we turn the back end around, same again, the curve should turn in, and on the other side the curve should turn in as well. And then I have got some stuff left over. So we've got these screws here and cable ties, and then we've got this wire. I don't know where that came from. We've got some spare standoffs in there as well. And then of course we've got this plate here, which I'm not going to use, but I thought it was nice that you actually get given some spares. This is that foam pad thing that's just not thick enough, so I didn't end up using that. I used this silicone one instead, and it does the job much better. So we've got the carbon fibre spanners, which I already mentioned, and the locking nut. So quite a lot left over, isn't there, after the build? And of course we've got the strap, which we need to fit to the copter, and it's the grippy kind as well. So I'm just going to move everything out of the way and fit this silicone mat here. So I've cut it to length and just going to fit it in the middle. Just make sure that it's not touching any of the screws, and then the battery strap is going to go through there as well. And then I'm just going to lock it in so that it's nice and tidy. Now I'm going to put this foam on the top here, and this is for potentially adding a Mobius Mini. I think it will reduce vibrations because they are susceptible to vibrations, but we've got a hole in the side, as I mentioned earlier, so we could perhaps put a strap through. And of course I needed to put the screw into the camera in the other side. I forgot to do it, and that is the copter completely built. So let's get him fly this thing. Alright, let's go for a maiden with this guy. Now I'm starting off in angle mode just to make sure everything is okay, but it seems it. And I'm listening out for oscillations, which I'm not hearing at the moment. So let's go for a punch test. This is the 650 milliamp 4S GMB battery. Wow, I was not expecting that. Orientation's quite tricky though, because it's a really dull day and it's windy as well, of course. So yeah, that has got a lot of power. I did not expect that. So I wasn't going to do a speed test with this guy because I thought, you know, oh, this one's not going to have the power, but actually I do plan to do future videos with this guy. Like, I want to add a Mobius camera on the top of it, so maybe we can do a speed run with it as well, and potentially add a bigger battery to see if we can squeeze some more amps out of it. Although I'm not hearing any change in the tone on the throttle, but we could potentially get even more power out of it, especially if we stick some gem fan flash props on there. But that's not going to be beginner friendly because it's going to be a rocket. In fact, I dare say, in this condition, it is a rocket. So you might want to start off with 3S. But I'll tell you what, these PIDs that I've put on here, line of sight at least, they seem to suit it. That doesn't surprise me though, because I have just copied PIDs from other copters of this weight and size, but it's feeling really smooth. We may be onto a winner here, and wouldn't that be amazing at this price point? By the way, spot the continuity error using a different transmitter in the build video. That's some stock footage that I made so that when I do build videos I don't have to repeat that bit every time. Bit of behind the scenes info for you there. But yeah, this thing seems to be flying nicely. Let's stick it back into angle mode to see if we've got any drift. Might be difficult in this wind, but I do that because it will show if there is any noise coming through to the flight controller. So that's hands off, drifting that way. If I yaw it that way, it carries on going that way. So no drift in angle mode, usually a good sign that we aren't getting any noise. So I mentioned earlier one of the concerns I had with this stator motor was heat, and these have come down completely stone cold. Now it is a cold day, but that is a good sign, I would say, for sure. It's made me want to try an 850 milliamp battery. So this is a Tattoo 4S R line. Let's give it a go. It might be the case that we get diminishing returns. It is 260 grams with this battery. So let's arm it. And what I'm listening for is sort of an audible and visual change in power. and I would actually say that it's got a little bit less power, but it still flies. And it's still got enough power The only thing I'd be concerned about is perhaps with the extra weight, you know, it could be pulling more amps itself. I mean, this battery will allow more amps, and also the extra weight will put more strain on the motors, so they could be heating up more. By the way, I've also had to borrow another battery strap because the Eachine battery strap wasn't long enough for this 4S battery. So what I'm going to do is bring it in and let's just check the temperature of these motors to see if there's anything. Nope, still stone cold. So actually I think you could go 850 milliamp 4S with this guy. Now I know this sometimes triggers a lot of people because the battery ends up being bigger than the copter, but you have to look at the figures, and I think you'd get an extremely long flight time. Anyways, onto the FPV. So let's take a look at some DVR footage, and to my amazement the camera performed really well. And check this out, we don't have any video noise. The only noise that we are seeing is breakup. Now you are going to need a decent antenna system to get good results out of this, so I'm using the Fat Shark HD3s here with the True Diversity module, along with a Omway cloverleaf and a Menace Bandicoot patch antenna, and you'll get the best results out of it from that. Now it's a very windy day, so it was getting pushed around a little bit, but it was just flying incredible, and I couldn't believe as well that with these PIDs it flew pretty nice. Now you might want to improve on them, that is fine, but these were fine for me. I wasn't noticing any prop wash oscillations, certainly not debilitating oscillations anyways. And guess what, this is the 650 milliamp 4S battery, and it gets over a 5-minute flight time. In fact, I think the longest flight time that I got with it was 5.5 minutes, and what I will do is I will cut the end of that flight into this one just to show you, because when it's a windy day you get shorter flight times because, you know, the copter has to battle more against the wind and that uses up more power. But yeah, I'm going to show you the full flight here, but I don't have anything to complain about. I guess, you know, I would have liked a 4x3 camera, but a lot of people getting into the hobby will be buying cheap goggles probably that are 16:9 anyways. But yeah, the range was really good as well. I took it out to at least 120 meters, which for this kind of model is fine. You can see we've got an inverted yaw spin there. Now when I do these cheap build videos, I think I upset a lot of people when I use the FR Sky radio and receiver, because that's more of a premium transmitter setup, and most people will probably be using Fly Sky because that is probably the cheapest transmitter and receiver setup. So I will explain to you how to set that up. So earlier when I showed the board, we had the S-bus and the PPM bridge. You need to bridge the PPM pad, and in Betaflight you also need to select iBus, and you need to change the channel map to AETR. As for soldering up the receiver, there are a few different FlySky receivers, so you can either buy a connector and solder it up, or solder it direct to your receiver, and I will put a link in the description for the i6X transmitter on how to set that up, and I hope that will help you out. But anyways, yeah, it was a long flight time, and I'm going to leave you with the rest of it. It might be a bit boring, but I like to show you the full flight just to show that there wasn't any hidden issues or anything like that. But I did struggle to find a decent day for the camera to have justice, because I did do a flight in the fog and the camera looked terrible and I didn't think it was fair. So yeah, the other flight where it got a 5:30 flight time was on a calm condition day, but it was foggy, so it made it look like the camera was all fogged up, when actually I'm really surprised how well this camera performs. So as I say, I will leave you with some flying. If you enjoyed this video and can afford to do so, then I will link to my Patreon in the below, because this video has taken absolutely ages. I think it's taken about a week in total. And as always, thanks so much for watching. Please continue to subscribe. Cheers.
Without you, I remember myself, my name. Forgot about all you tried to change. Familiar was the sound of your voice as I continue to walk on by. It has been a year and now I'm living on the line. It has been a year and now I'm thinking what's mine, that I'm better off right here without you. I admit that I've lost my place. My memory's gone erased, like a scratch only